peristalsis. So I'm going to mention the term peristalsis. Peristalsis makes a direct reference to the contractions that you would experience or you could observe of the digestive organs. When your stomach churns or when your small intestines are contracting to allow the passage of food, is that something that's under voluntary or involuntary control? And that's a nice way of saying that you don't choose to do that. It just happens naturally. Now, when that's occurring, what type of muscle system or what type of muscle tissue is responsible for that? Smooth. Good. Now, if you're like, well, that I didn't know that. You never taught us that. I did on Monday. So definitely you see that there's a put together phase of both of all this stuff that we've been talking about for the last couple of days. So really want to make sure that we see that it's all connected together. The last thing I want to mention as a general principle is the term sphincter. Which is going to make reference to a valve that allow or that regulate the passage of stuff. So kind of like a doorman, no pun intended, there is a regulatory event here. Okay. Can you go through or can you not go through? Good. Okay. I think now's the time to go ahead and bring out my friend. Named him Bob. Okay. Don't really need this at all. Good. Okay, so here we have the heart, correct? Good. Oh, this is the wrong system, so we don't need that at all. So I'm going to go pull out the liver for just easy observation. Right here. Mouth, correct? Duh. Good. Salivary glands. Good. Makes saliva as well. A couple other things we'll mention. Two holes, two ports to go down. One's called the trachea, which is the windpipe, or the larynx. And the other one is the, what? Esophagus, right. And the esophagus actually, you can see right through here. So you see that orangish colored portal. Can I move it? Yellow portal. That's the esophagus. Now you notice the esophagus because the esophagus is going to lead right down into the stomach, right? And this right here is your stomach. Not your stomach, it's Bob's stomach actually. And you'll notice that there's like an opening that's going into the stomach from the esophagus, correct? Yes. That opening is going to be right here. So here's your first sphincter. The name of the sphincter is cardiac sphincter, right there. You think cardiac, what do you think? Heart. This is obviously a stomach, not a heart, correct? But here's the reason why you would call it that. If this sphincter fails, which is hard to say if you think about it, if you try it, if it was to fail, then you would have a backflow of acid the direction up the esophagus. Now, gravity, of course, right, not the John Mayer song, the real thing, would stop you from having acid beyond about this point, correct? Oh, which is right behind the heart. So what do you have? What condition? Heartburn. Not because of love, but because of acid in the esophagus. Good? Okay, perfect. Pyloric sphincter, exiting out of the stomach. See that right there? Okay, good. Exiting out of the stomach into the small intestine. Oops. Oh, I'll get it. Small intestine, right? So here's the small intestine starting. And they show you like this cute little drawing right up front. There's all the small intestine. Post the small intestine, then it's time to go to the large intestine, which we're going to start right about here. And we're going to do this long movement, drop down. You don't see the drop down part because it actually is right there. Cool. Looks like a question mark if you think about it. So right, it's got the ascending transverse or transducing, I think, I forget what it is, and then descending portions of the colon. So it's really cool. So there's the small intestine, the large intestine. Cool. The accessory organs that are involved are going to be like your pancreas, which is shown on the back here. You have your liver right here, gallbladder right below that. Cool. So you have a lot of little pieces here that are very, very important to your digestive system. Good. Our task today is really going to be to go from the mouth to the start of the large intestine. If we can get we can get to the colon today, I'll be happy. Yeah. Okay. So we got to put him back together now. This is always a very difficult task. I'll just package this in here for now. Bob's not alive anymore.
What happened?
What happened?
Yeah.
I don't know. Does it look right to you? I don't know.
That's okay.
It was like Harvey Dent.
You don't look at this that normal.
Oh yeah, that really doesn't look right at all.
Signature message.
I think Bob's I'm pretty sure Bob's a chick.
I don't
Okay, so let's go ahead and talk about all these pieces. We won't be able to make it to our exit point today, no pun intended, but we will be able to make it to we'll be able to make it close to the exit. And you know, if we can just get beyond the small intestine, I'll be happy. If we can get to the large intestine, we'll be good. So let's talk about the anatomy real quick of this system. Now I'm going to need you to draw this, and everyone, they draw today like, Mr. Fields, what are you doing? You can think initially that you can pretend this is like a 4th grade drawing. It's not. There's a reason I'm going this direction for this drawing. But whatever. I'm sure you'll make fun of it accordingly. Again, I know some of you guys are like, wow, that's horrible. It's actually really good. You'll thank me later. Then here we have the esophagus. What's our next stop after the esophagus? Perfect, stomach. Then this right here is the small intestines. Then the large intestine. The reason for all the purple, those are your accessory organs. Salivary glands. We have our pancreas. And then the closely associated liver and gallbladder. Right through there. Yeah, so we have all of our little pieces. And I think our next step is going to be a discussion on what each of these pieces does. And I think a majority of this is going to be pretty straightforward, pretty simple stuff. So let's go ahead and talk about this. So we'll start off by talking about the mouth, about the oral cavity, kind of interchangeable, obviously, on that system right there. And again, what we'll dedicate this part to right now is kind of what's going on, little tidbits about regulation maybe. First off, in the mouth, you're going to have two types of digestion. You're going to have both a mechanical style of digestion as well as a chemical digestion or breakdown. And let's go ahead and talk real quick. What would the mechanical breakdown be here? To chew, right? With the teeth. And then the chemical breakdown is going to involve the salivary glands. So let's go ahead and include them real quick. And let's talk about what your salivary glands are going to be doing. One obvious fact it would be maybe sometimes not as obvious, is that they're going to work to create a liquid that's going to lubricate the food so that it flows down the pipeline, the esophagus, well. And the other thing is that they're going to produce the chemical that's responsible for some of that breakdown we had mentioned in that first bullet. The name of that chemical, the name of that enzyme is salivary amylase, which of course is going to be responsible for carbohydrate breakdown. Carbohydrate?
No.
Amylase, amylase. That's just kind of referring to general carbohydrates. So carbohydrate breakdown. And because of this, all this action, then you throw in the tongue, the little papillae on the tongue, which of course are sensing the food that runs to the brain. So you've got all these things going on as far as like your brain's work here. The tongue also is working to shape the food into a structure called the bolus. So the food is shaped into a bolus. And then from here, the food enters into the esophagus. So food enters into the esophagus.
Wait, so it shapes the mouth and then...
Exactly, like your tongue is working on making this little ball of food. And so when you do the gulp bit, you're gulping down a little ball of this big of food. Good? Seems gross, I guess. It's the circle of life, like the Lion King told you. It's the same thing. So, bad jokes today. No one gets it. Epiglottis. I'll work on new material tonight, I guess. Does anyone know what the epiglottis is?
Is it in the back of your mouth?
Yep, the little ball hanging down the back of your throat, right? What's the purpose of that little ball at the back of your throat? Vomit?
Yeah.
It can be a gag reflex. That's not what I'm thinking its purpose is, though. The ball drops. Just like at the beginning of the year.
So the food doesn't get on you.
Booyah. So this is going to be a blocking agent of the trachea. Blocks entry into trachea.
Is it possible to get removed? Or is it common?
I would hope not. I don't think so.
Well, like they shorten mine and they don't like all.
No, I think you can
I think I
Yeah.
got like part of mine removed.
you might have some of it gone. Absolutely. But you can't remove the entire thing.
Okay. Yeah.
Like you can't take the covering over the trachea because then you run this risk of having the choking aspect. Yeah, so this is going to prevent choking.
Yeah.
And when I say choking, I mean choking on food, not like choking as in I choked during Pee Wee football, you could say. I'm not talking about that kind of choke. I'm talking about choking as in to not breathe. Now, is this something that you control? Do you make this decision for the epiglottis to move? That means it's got to be smooth muscle movement, which means it's going to fall under the voluntary or involuntary processes. Involuntary. Just like if I was to call out someone's name right now, that would be involuntary because you're not volunteering for that. I'm volunteering you, myself. Thank you. Thank you. The next stop, not really a stop, a portal, the esophagus. The esophagus is going to be what carries your bolus, carries your little food particle. Not food particle, don't want to say that. Carries your food ball to the stomach. And you're going to enter the stomach, so there's going to be entry through the cardiac sphincter. I like saying that, not because the word sphincter is so much fun to say out loud, but because I like that you see that you throw the word cardiac, which means heart, and it's not even the heart system. Kind of shows you that how the name it sticks to the feeling that you have and not what the real system is. Because obviously this should be stomach sphincter more so than cardiac sphincter. So it's easy to remember that way. And then, of course, I can throw down the word peristalsis, or throw up the word peristalsis, however you want to say it, if it's throw up or throw down. Ooh, that doesn't sound right during this lesson, does it? What is peristalsis, though, still?
The squeezing of stuff downward.
Still the contraction.
Contraction.
So the contraction of what?
What moves the food through the esophagus and the stomach? It's like squeezing and stomach churning.
Right, so it's still the contraction of smooth muscles, right? Of smooth involuntary muscles. And that's what's bringing your food downward, as well as gravity, because gravity tends to bring things in the downward direction. Our next stop, and looking at the time frame of things, this is like been minutes since you chewed the food. Minutes, to just maybe a minute later, you've got the food entering the stomach, and this next stop is going to take a little bit of time. The entire process, by the way, takes about a full day to occur. Just throwing that out there. So from about the time that you ingest, you put down in the mouth area, it's about a day later that it's ready to come back out. So the next stop is the stomach. That's about 2 or 3 hours, which is why if you were to try to throw up, or not try, but if you were to, for whatever reason, throw up or more than like 3 or 4 hours after eating, you probably won't have anything come up aside from acid, and that's because the food will have already made its passage into the next portal, the next area. Okay. As far as what's going on here, your stomach is going to secrete gastric juices. So I'm going to say it secretes gastric juices. Everyone hates me using the term juices because I think they think of juice box. I actually like using it, so I'm going to continue to use it throughout today. I'm thinking of 2 types of juices. I'm thinking of the juice pepsin, and I'm also thinking of HCl. That's HCl stands for hydrochloric acid. HCl. And it's during this time frame that your food ball shows up, and the stomach's going to work to convert the food bolus into acidic chyme. Now I know that looks like you would pronounce it chime, but chime is like a bell, and this is obviously not a bell. This is the stomach and breakdown of food. So definitely not chime, and I would say chyme would sound better here. Good. The parietal cells work to secrete H+. That's parietal. P-A-R-I-E-T-A-L, parietal cells. Secrete H+, as well as Cl-, but they do so separately. Now, as you could gather, though, there's for sure your HCl when those two show up in a combo. Your chief cells, and those are 2 types of cells that line the stomach, they secrete pepsinogen. Now, if you remember from before, I had said that your gastric juices were made of a combo of pepsin and HCl. And I think you were all here when I had mentioned pepsin and HCl. Now, pepsinogen sounds like pepsin, but it's certainly not pepsin. Good? So let me show you what's going to happen. The pepsinogen is going to be there because the chief cells are going to make it. So here comes pepsinogen. And pepsinogen basically is your inactive form. It kind of looks about like the right thing. It looks like pepsin, but it's not exactly pepsin. So somehow we have to take the pepsinogen, convert it to pepsin, which is its active form. Now to do this, you only have to do like a slight little modification. Now, it would make sense that who would be responsible for this conversion? Who do you think shows up that allows this conversion to happen? I'll give you a question. Who else is showing up?
Food.
Well, food is, but HCl is. So HCl, an acid, causes a protein to change structure. Now, have you ever seen that before? An acid causing a protein to change structure? Yeah, you have? You personally have seen it?
No, not me.
Yeah, you have. You all have. No, you all have. When did you all see it? Close. Chapter.
4. 6.
It was actually 6. But you saw it during the catalase lab. Do you remember that? Catalase, what did it do? Broke down what? Hydrogen peroxide, right? And then we had catalase, we had to shut down that enzyme. We added what acid to it? Do you remember? I should start giving out bonus points for people that can get my questions. We added sulfuric acid to it. Do you remember adding sulfuric acid to it? Catalase then died, the enzyme stopped working, right? So you have seen an acid change the shape of a protein, right? To cause it to not work. Agreed? Now you're seeing an acid change the shape of a protein to actually make it work. Good. If you were going to engineer it, you'd engineer it this way. Now, as far as like what your pepsins, because I've mentioned pepsin and it seems like it's all so important, what it's going to work to do is it's going to work to start protein digestion. Which kind of makes for a good question, because if you think about carbohydrate digestion, that actually starts in the mouth. I'd mentioned that before. You're like, no, you didn't. Yeah, I did. Right about here. So carb breakdown starts in the mouth, but protein digestion actually begins in the stomach. So now we got that at work for us. Oh. How about them apples? Actually, apples are a carbohydrate, so how about that steak? Get it? Protein? No one got it. Okay. No, it's not. Don't lie. There's also mucus that is used or that is found to protect the lining of the stomach. So the lining of the stomach is protected by mucus. Good? Oh, awesome. In the event that this was missing, then you could have a problem with like the stomach lining being combined with or in front of too much HCl, which could never be a positive thing. And then lastly, I'm going to throw in the word peristalsis. And we all remember what that is, right? Because this is now the third time you've heard the term today. Contraction of smooth muscle tissue. And you would find that in the stomach too. And you're like, no, you wouldn't. Yes, you would. Everyone's stomach has churned before. Probably your stomach has churned today. Because it churns even if you don't hear it, it's still churning. It has to. Because you're continuing the mechanical breakdown of the food so that it can become the liquid form, the acidic chyme. By the time that this process in the stomach is over, after about 2 or 3 hours post-eating, that food needs to be very acidic and very liquid. And you know that's the case because you all have experienced a case where you have vomited a couple hours after eating. There's your food. Your back of your throat burns very heavily, and the food looks very liquid. Oops. Good? Okay. No, I mean, not good for that, but good with material? Very, 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 very nice. Next stop, where? Very good. It's not so much excitement. The next stop is going to be the small intestine. Now, if I was to ask you, what do you think the major organ of the respiratory system is? What would you say? The major organ of the respiratory system? Lungs. Major organ of cardiovascular? Okay. If I was to say major organ of digestion, a lot of people would say, well, there's the liver, there's this, there's a lot of good ones, but I would put this one as your major one. So I want us to know that the intestine is not only the longest section, but I think it's the most important section. So I'm going to write that it's the major organ. Now, then everyone's like, well, why would me, the wizard of biology, Mr. Fields, part-time DJ, why would he say that this is his major organ? Why would I go this route? And here's the reason why. Is because this is going to be your major site of absorption. In fact, it's not just the major site, it's really the only site. Major site's my nice way of saying the only site of nutrient absorption. And also, before that, it is serving a purpose as a continuation of the actual digestive process. You know, I've already mentioned that carbohydrates started where? Okay, in the mouth. And then protein digestion started where? And everything's going to terminate, will finish, will continue will run to completion, digestion, and that includes the fats and the nucleic acids that I have yet to mention. Everything will either start, stop, continue, get finished. By the time that you're done with that first side of the small intestine, you've broken down everything. And then the rest of the small intestine is dedicated to absorption. So this is the Booyah organ right here. Good? Now, because you have so many important things going on, we divide this into 3 sections. So you have 3 sections in your small intestine. The areas are the duodenum, the ileum, and the jejunum. And you might have heard those terms dropped before. I'm going to first start off with the most important, the duodenum. I say most important, the one that gets the most playtime from your book, the duodenum. Duodenum is going to be your first section of the small intestine of SI. By the way, SI here means small intestine, not Sports Illustrated. Someone asked me that earlier, and the answer to that was no. It's in here that your acid chyme enters. Enters from the stomach. Remember, the stomach was the prior stop. The pancreas, the gallbladder, the liver. All work as the accessory organs to deliver juices, there's my term juices again, to the acidic chyme. So again, all 3 of those accessory organs, and there are, you can throw in more. I like to throw in these 3. Your book mentions these 3 as the primary ones. They'll all work to start delivering things to the small intestine. That's why I call it the massive site, because you can see where all the other organs that you've heard before, they're all connected to that small intestine. So that's got to be a very, very important area. Let's go ahead and maybe generate and spend a little bit of time talking about the role of each of these organs. So I'm going to give pancreas some time. Throw some time to my liver. Talk about the gallbladder. Run through all these important concepts. Your pancreas, this is everyone's pancreas, for sure, is going to work to produce a chemical called trypsin and chymotrypsin. So it produces trypsin and chymotrypsin. Produces trypsin and chymotrypsin, which actually are going to work to continue protein digestion, which began in the mouth, right? That's where protein digestion began, right? No. The stomach. What was the name of the enzyme there? Amylase, right? Pepsin. Which was activated by HCl, which was made by what cells? HCl was made by what? The parietal cells? Then what made the pepsinogen? Chief cells. Okay, good. These guys have a basic pH. Basic pH. That's above or below 6? Above 7. My bad. Wow. Above 7, right? What are you going to do with something so basic? What would a base do? Oh, goodness. Neutralization of the acid. Neutralizes the acid. Your liver produces a variety of other gastric juices. I want to focus on one type of, I don't want to say maybe necessarily juice, but one type of chemical or group of chemicals that's formed. Those chemicals are called bile, or bile salts. Your book might refer to them as bile salts instead, which are chemicals that are, 1, stored in the gallbladder, and 2, serve a purpose of fat breakdown. So now I've given something for the gallbladder, which is going to be a bile storage facility. Now again, bile is not just one compound. Bile is like a reference to a variety of different compounds that are kind of all serving about the same purpose, and that is to really work together to break down fats, or to get fats broken down into as small a piece as possible, and also like a finalization of all of the breakdown that you can do, a finish of digestion, if you will, so that you're ready for absorption in the ileum and jejunum, the second and third parts of the small intestine. Make sense? So like we gotta completely finish breaking this thing down. So let's break it down. No one got that one either. So the liver. Cool. Right below your liver is the GB. What does that stand for? Great Britain, right? Gallbladder. And we have a tube running from the gallbladder directly to your small intestine, which I'm going to draw like this. You're like, Mr. Fields, you've just drawn squigglies. I realize that. But that's about what the small intestine looks like. All crazy shape. Bunch of little Vienna sausages, honestly. So, good? The name of this connecting tube, does anyone know the name of it? Do you? I do. Yeah, I'm asking you. Close. Wow. How about the common bile duct? It had the B in it, so that's why I said it was close. Common bile duct. You guys have heard of this before, right? Wow, okay. Well, here's what happens, is you have bile that's produced in the liver, stored in the gallbladder. So I'm going to draw like my little marker arrow this way, this way, this way, this way. Perfect. So it looks like that. That's your movement of bile salts. Now what that means is that you have a storage unit of bile salts, which means that you don't have to go searching for bile when it's time to use it. You already have it stored up. Now, what do you know about some people? Tell me about their gallbladder. Yeah, it's MIA, not the band, the real thing. It's missing in action, which means that it's gone. So I'm going to put like a very slight little X through this, and I'm going to say the term removed. So if this was removed, here's what you have to do. You've got to repipeline this CBD, that stands for common bile duct. You'll repipeline it directly from the liver to the small intestine, CBD. Again, that stands for new common bile duct. Now, what does that mean? Well, you don't have a storage facility for your bile, which means your liver has to produce it about the time you need it, and the liver's not so efficient at that. So people that have their common bile duct their gallbladder removed, sometimes have to watch the fat intake that they have, because they don't have the bile salts there to break it down. Sometimes it just passes right on through. You know what I mean by that? Question.
Is that like when like the bile salts crystallize in the gallbladder?
Well, that can happen sometimes too, and those are called like stones, basically, like gallbladder stones. Like you can have like urinary stones, basically, like produced by the kidney, stored in the gallbladder, or I forget when it crystallizes or when it calcifies, but probably post-kidney for sure. You can have the same thing here, like the same problem, which is why like there is the removal of the gallbladder option, which is a common enough procedure. The problem is that, you know, like when you need something and you go, I don't want to say farm it, but you go like in search for it, you know, and you store it up. Well, when you need it, it's very easy to go get because it's in your storage facility. Now, if you had to make it like as you needed it, you're going to have a little bit of a delay. That's the problem those people experience. Another problem that's very common with your CBD or common bile duct is for a lot of digestive cancers. A lot of digestive cancers happen in this area. Now, problem with this is that this area, and you can't see because Bob's sleeping right now, but if Bob was back, you would see that all this stuff is very, very close together. And a digestive cancer a lot of times will run a risk of pinching off the common bile duct. Now, what does that do? Well, that prevents this arrow from completing. And you have bile salts, which are very toxic because they're all about breaking down stuff. They actually flow through the bile ducts. They get reversed because there's a blockage. You run back into the liver. Now, your liver is producing a detoxification poison, basically, bile. What happens when bile re-enters the liver? It's like poisoning the liver. What happens? Within 2 or 3 days, the individual will likely die. You'll know that this is close because of the jaundice. And you probably have learned along the way in world history. I forget, there were a lot of cultures that when the yellow body appeared, they knew death was imminent. And that's what the jaundice basically is the yellowing of the skin because of the black flow of bile. It's very common in a lot of digestive cancers, yes. I know several people that have died of like pancreatic cancer or liver cancer, and typically what causes their death in the end, we're not done yet, by the way, so don't even put away your notes. What causes their death is actually this. Not like, again, the way cancer works is cancer doesn't produce little chemicals that makes you so sick you can't live anymore. It causes a tumor, and the tumor blocks some kind of physiological function. Here's the blockage this time. A brain tumor causes a block of blood flow in your brain, so you die of basically a massive seizure or like a massive stroke, probably. Cool. So we're basically done, but we're not almost. I mean, we're almost done, but we're not 100% done. We still have the ileum and jejunum to talk about. Now, don't be scared. This is all pretty simple stuff. What is your ileum and jejunum doing? Well, I'll tell you right now. I'll break this down for you. No pun intended. Actually, there is no pun at all because you've already done your breakdown. Now it's time to absorb. That's what's going to happen in your ileum and your jejunum. So you're going to absorb your stuff. And you're like, Mr. Fields, what are you going to absorb? Probably nutrients because this is the digestive system, of course. Now, to help us with absorption, we have seen several times throughout the class, this is why this makes such a strong AP test question, is for connecting different things, but you have this surface area thing again. That's why you have the little microvilli finger-looking projections in the small intestine, and they do look like little fingers. Now what that's doing is that's allowing for an increase of surface area. More surface area, more absorption, which means more food's coming in. I always like to play this off like with another example. The other example could be pumping gas in your car. Would it be intelligent for you to have a ratio of 4 gallons in the car and then 1 gallon on the outside sidewalk? That would be retarded, right? Well, you don't want that. That's a waste, right? So what do? You work very hard to make sure that that little nozzle is in the tank, correct? As difficult as that may seem. Well, that's the way your body is designed as well. You have these little finger-like projections that will increase your overall surface area. More surface area, more absorption, which means that when you make the deposit, when you go the number 2, you are only number 2ing out the waste product. Don't leave yet, forget that bell's even ringing. Now, each little microvilli, I need about 1 minute and 20 seconds, which you guys have SOC, and you know, I'm workable with that. Your little finger-like projections, your little microvilli, they all have lacteals attached to them. A lacteal is a little blood vessel. Now this is starting to come around about. Not the song by Yes, if anyone's ever heard that band. We've got lacteals which are picking up those little nutrients, correct? So nutrients. This is good. Finally, we're getting some food in the blood, so that the blood is not carrying your food. So you have food particles being delivered to all parts of the body. Makes sense. Straight? Now, the thing I'll mention next is that all these little lacteals coalesce into something called the hepatic portal vein. When I say the word hepatic, what does hepatic make reference to? Liver, always. Hepatic, liver. So you have the hepatic portal vein, and I'm going to get back to the vein part in a minute. Hepatic portal vein is where all the lacteals coalesce together, and you run this food through the liver. Now, what's the liver in charge of doing, aside from producing bile in its spare time? What is it doing? It's a detox center, right? It's like, it is the site of detoxification. It's like the Betty Ford, if you will. No one gets that joke either. Y'all need to look that up sometime. It is the detoxification center of the body. Now, I will add that vein, last part, vein. What are veins doing? Carrying blood. Neat. Which direction? To the heart. Arteries are always away from the heart. So what does that mean? What type of blood is going back towards your heart? Not dirty blood, nutrient-rich blood. What does that mean? Well, when your blood goes to your heart, it's going to do a circular fashion we'll talk about soon that reoxygenates it, so that when that blood leaves that heart, it's nutrient-rich and it's oxygen-heavy. What are the two products, or the two reactants for what reaction? Cell respiration. No, I do know. The question is, do y'all know? Have a good day.
Take it easy, man.
I will, man. Tell your friends about my class.
Mr. Fields, one of my friends is actually taking your class.
That's really cool.